Good morning, boys and girls. So today is one of our, last 3 lessons for credit recovery, and we are going to be discussing segments, which means pieces of a line, inside and outside of a circle. So if you look at these pictures, we've seen these pictures before. We just talked about these angles that are formed when these kind of segments are drawn in a circle, like if I have 2 chords, or if I have 2 secants, or if I have a secant and a tangent. We've talked about their angles, but we did not discuss the lengths of these lines. So I'm just going to briefly discuss the difference between if the segments are inside or if the segments meet outside of the circle. So in this first example, you could see we have 2 chords. So one of the chords, so we have a chord that is AD, and we have another chord that is BC. And if you notice, when these chords intersect, you create 2 parts in one chord and you make 2 parts in another chord. So in chord AD, you make segment AE and segment ED. And in BC, you make segments BE and EC. So really, that's exactly what the formula is when you're trying to find the lengths of those segments. You have the 2 parts of one chord multiplied with each other equals the 2 parts of the other chord multiplied together. Oops, I did not mean to put that S. So it's PP. PP equals PP. Just a nice quick way for you to remember it, that part times part, and they have to be of the same chord, equals part times part. If you need to copy that down, please do so. In the next one, we have 2 secants. So a secant passes through the circle twice, just in case you forget. So if you see 1, 2, and it passes through twice, that's what a secant is. Now notice these 2 secants meet out here at point E. So one secant is EA, and the other secant is EB. So in this formula, we talk about the whole secant and its exterior segment. And this whole secant and its exterior segment. When I say exterior, I'm talking about outside the circle. So that's the rule for this one. And the little trick to remember that is it's the whole piece times the exterior equals the whole piece times the exterior. So that's we. I hope I haven't made you need to use the restroom at this point. And in this last picture, we have a secant and a tangent. Now the secant is AC, and the tangent is from A to D, because a tangent only touches a circle once, and then we'll keep going. Only once. So for the secant, the rule doesn't change. It's still the whole times the exterior, which is AB in this case. And then the tangent, we don't have a whole and an exterior, so really it's the tangent and then, the tangent again, which, almost is considered as the whole times the exterior anyway. So this one, a little trick to remember this is whole times exterior equals tangent times the tangent again. So if you haven't already figured it out, this one is called wet with 2 T's. So those are the rules for segments inside and outside of a circle. We have pee-pee, wee-wee, and wet. At this point, if you need to pause the video to use the restroom, I would completely understand. But let's try some practice problem if you're ready. So here are 3 examples of using the rules. If you notice here, we have 2 chords. So the rule here will be pee-pee. So part times part equals part times part. Now remember, it has to be of the same chord. So if I talk about this chord right here, that chord, the 2 parts are 3 and x. Then for the other chord, the 2 parts are 6 and 4. So 3x equals 6 times 4 is 24. And then if I divide by 3, I get x equals 8. Now if I look at the second example, in the second example, I have a secant and a secant. So this rule is wee-wee, whole times exterior equals whole times exterior. So now if I focus on just this secant, the whole thing is 10 and 14 together. I'd have to add them. So 14 plus 10 is 24. So my whole is 24. And just my exterior there is 10. And then the whole thing here, if you look, they did a dotted line to represent the whole thing here is x. And then the exterior piece here is 8. So we get 240 equals 8x. And then we get, when we divide, we get that x equals 30. So the whole length here is 30. Now just as a side note, if the whole length here is 30 and this piece is 8, what is the length here? Well, you have to ask yourself, what's 30 take away 8? And you get 22. So this remaining piece here is 22. It's good to think about because you never know what they ask you in the problem. Now if I look at this last one, I have a secant and a tangent. So this is going to be wet with 2 t's. So I have the whole thing here has to be 8 plus 4, which is 12. So the whole is 12. And the exterior is 4. And then the tangent is x, and I write the tangent again, which is x. So 12 times 4 is 48. And x times x is x squared. So I have to square root to solve for x. I get that x equals the square root of 48. Now, technically, the problem does not say to simplify, so I can leave it like that. Or, I would not want to do the decimal because it did not ask for it. If it did, though, if I were to round it, this is approximately. So I'll show you other possible answers. So this is approximately 6.9. Or, if I wanted to simplify the radical, I have to ask myself, what's the largest perfect square that goes into 48? So I know I could divide it by 4, but I also know that I could divide it by 16. So 16 is a larger perfect square. 16 times 3 is 48. So the 16 comes out as a 4, and the 3 stays inside the radical. So this is if you need to round it. This is if you need to simplify it, and this is also acceptable if neither is expressed how they want the answer. So in all of these practice problems I give you, I don't specify how I want you to leave your answer. So you could leave it as an exact answer if you want. So there's a whole bunch of examples you could do here. So pause it wherever you need to try these practice problems. And then when you come back, you could check all of your answers. I'll make sure all the work is there for you. So there's 17 questions. So pause it now, try them out, and come back and check your answers. Good luck. Okay, so here are the answers to the practice problems. You can pause it wherever you need to. Check the work. So I made sure to express in each problem if it's a pee-pee, a wee-wee, or a wet. So based on if I have two chords, two secants, or a secant and a tangent. So if you take a look here, all of them are set up. You could pause wherever you need to. I could even zoom in so you could check out all your answers, all the work. Pause wherever you need to pause it. So here's 1 and 2. Here's 3 and 4. Here's 5 and 6. Here's 7 and 8. And notice that at the bottom, if it tells you 2 decimal places, that's when I rounded. Number 9, 10, 11. So notice how when I do the whole thing, if there's an x here, I make sure to mark it as x plus 10. But I couldn't combine them, so I just use x plus 10 as my whole. So that happened a handful of times in these problems. Here's 12, 13, 14, 15, 16, and 17. So if you have any questions, please make sure you reach out to me. Have a great day, everybody.